Algebra 2 Cram, New York State, Algebra 2 Regents, Common Core, Trigonometric Function Basics, the Unit Circle, Concept number 5, Quadrantal Angles, 180 degrees. The odds of someone doing exactly what you tell them to do is pretty slim, but I guarantee that if you cram with me, you'll become an Algebra 2 master. What we're doing here is so effective. I'm coaching you to turn your wants and desires of getting an A or perfect test scores into a new paradigm. I want to include everyone who needs a boost in Algebra 2. If I could stick every math student with a syringe containing a healthy dose of eye-opening awareness of their inner mathematical genius, I probably would. So inbox me at memedicine@gmail.com to order this complete cram session. You have lots of peers, classmates, and or colleagues who could really benefit from this cram session as well, so be sure to spread the word to them and tell them to inbox me at memedicine@gmail.com so that they too can order this complete Algebra 2 cram session. And you'll want to spread the word because they'll make great study buddies. Last, the concept of cramming gets a pretty bad rap. That's because people are actually associating cramming with hurrying. Hurrying results from fear and can consequently be destructive. We're not hurrying here, okay? We're cramming, there's a difference. Hurrying is jam-packing tons and tons of unorganized information into your mental, spiritual DNA over a tiny amount of elapsed time, whereas cramming is taking quantum leaps in your understanding in what seems like an instant. So let's delve into the concept of the unit circle and the quadrantal angle 180 degrees. Trigonometric values for quadrantal angles 180 degrees. What are the exact sine, cosine, and tangent values for the quadrantal angle 180 degrees? Definitely press pause if you need to, and I'll give you a moment to think. While you're coming up with your solution, in case you forgot, a quadrantal angle is an angle whose terminal side is on the x or y axis in any direction. Okay? All right, so hopefully by now you are able to arrive at an answer, and if not, that's completely fine. I need you to recall that in Cram Session 2 of this series, we established that the unit circle radius has a measurement of 1 unit in any direction, okay, whether in this direction, that direction, this direction, this direction, that direction, it's all 1 unit. And I also want you to note, this is an aside, that theta here is an acute angle in the standard position. When I say standard position, I mean that the vertex is at the origin. The initial side ray terminates at this x-axis, and the terminal side ray forms the hypotenuse of what we're going to see is a right triangle, and it has a y-coordinate at this level. Okay. All right. So because the unit circle radius has a value of 1 unit, this really simplifies finding all sorts of trigonometric values, okay? First, because let's say, for example, that this point is P. It has an x-coordinate and a y-coordinate at this level. P would be the point of intersection between the terminal side of our standard position angle theta, which is acute because it's bound between the quadrantal angles 0 degrees and 90 degrees, and it would be the point of intersection between the unit circles. So it's the point of intersection between the terminal side of our angle theta and the unit circle. Okay? Then for these reasons, the cosine of theta is going to be the x-coordinate, and the sine of theta is going to be the y-coordinate, but I'm going to show you why, okay? All right, so let's say we were just dealing with a regular triangle. that were not inscribed into a Cartesian coordinate plane. Because this angle, well, actually, let's go back to the Cartesian coordinate mindset. We're resolving this hypotenuse, or this ray, or the radius, into its x and y component. And what we can imagine in our mind's eye is a right triangular formation, okay? And so the extent of the resolution of the x coordinate goes to some value x, and the extent of the resolution of the y coordinate goes to this level, some value y, okay? But let's extract this temporarily from our Cartesian coordinate plane, and we know that the cosine of any angle theta is going to be the adjacent side divided by the hypotenuse, okay? So let's represent that. I think in a previous session I might have just said the adjacent side. That's wrong. Divided by the hypotenuse, which in our case is 1. That's really convenient. And the sine of any angle theta is just going to be the opposite side. So this theta right here has an opposite side whose value is y, divided by the hypotenuse. So we're going to go ahead and represent that, okay? So the sine of theta oh, sorry for the lag. I know this takes up so much seconds, equals y, or the extent of the opposite side, divided by the hypotenuse, which in our case is 1. And because the hypotenuse has a 1 unit value measurement, we don't have to indicate it. It's implied. Therefore, we get that x is equal to the cosine of theta, which I didn't write here due to lag time, and y is equal to the sine of theta. Hence, our representation here. Okay, so these are essentially our starting points to really answer the question of the value of all the trigonometric functions for the angle 180 degrees. Okay. All right, so let's delve further into the answering the question. So because of these truths that we just established, with the cosine of theta being x and the sine of theta being y, this greatly simplifies finding specific trigonometric values for all the quadrantal angles. It makes it so easy. I'm going to show you in a moment why, okay? All right. So because we know that the unit circle has a radius of 1, it's centered about the origin, we know that the measurement or the extent of this radius is going to be -1, and it doesn't extend in any direction vertically, so the y-coordinate is 0. Therefore, and also know that don't be alarmed when seeing this -1, because when we do the actual measurement of the radius calculation, the x-coordinate always gets squared, so -1 can be legit, okay? So we know that the cosine of theta is -1. We're going to go ahead and fill that into our table. And we also know that the sine of theta is going to be 0, okay? Therefore, our tangent value is just simply going to be the adjacent side to the angle divided by the imaginary opposite side, so it's going to, no, actually it's going to be the opposite side divided by the adjacent side, or sine of theta over cosine, which we have here. So 0 divided by -1 is simply going to be 0. It's a derived quotient trigonometric function, okay? All right, so that answers our question pretty much. And the intellectual comprehension of this material is not difficult at all, although I kind of went in a few circles mentally. And after the short amount of time it takes to complete this entire cram session, you'll be prepared to answer a battery of questions concerning Algebra 2. So inbox me at memedicine@gmail.com to order this complete cram session. Good luck studying.